Let's look at two examples of how to solve quadratic equations using the quadratic formula. So the first example, you can see here we have a quadratic equation in standard form, which means we have the 0 on one side, right? And since we're going to use the quadratic formula, the first thing that we should do is go ahead and decide what a, b, and c are. So a is the coefficient of the x squared term, so that's 2 in this case. B is the coefficient of the x term, so that's 3. And c is our constant, which will be -4. And notice how I did take the sign in front of the 4 as part of c. And now what we're going to do is we're going to substitute a, b, and c into the quadratic formula, which I'm going to remind you as we go along. Well, actually, let's write it down. X equals the opposite of b plus or minus, write a big square root, and put b squared minus 4ac under the radical, and then all over, so make sure you put a big bar here, fraction bar here, all over 2a. So x equals the opposite of b, which will be -3 for us. Remember, b was 3, plus or minus the square root of b squared, so 3 squared is 9, minus 4 times ac. So a times c is -8. All over 2 times a, which is 2 times 2, or 4. And then in this radicand, we are going to do multiplication first. We're going to multiply these -4 and this -8 together first before we add the 9. Be careful here. So we're going to get the opposite of b, -3, plus or minus the square root of 9 plus 32. 4 times 8, right? All over 4. And then we're going to add together under the square root sign, the radical, -3 plus or minus square root of 41, all over 4. And since 41 doesn't have any perfect square factors, we are done. This is our, so we ended up getting 2 answers, right, as we expected for the quadratic, right? We got -3 plus square root of 41 over 4 as one solution, and -3 minus square root of 41 over 4 as the second solution. And what kind of roots are these? Well, these are irrational roots, right? That square root of 41, we're getting irrational solutions. And then a reminder to you that we can use our calculator with the Stow key to check those. So let's go ahead and do that now. Okay, so let's look for a calculator. So I want to show you, I went to my calculator and I decided I was going to check the first root, which is -3 plus square root of 41 over 4. And I was being lazy with my parentheses, so I went ahead and typed in -3 plus square root of 41. Then I hit enter. Okay, gave me the decimal. Then I hit the division by 4 key, divide by 4, and picked up my answer from before, which is my numerator, and then gave me that decimal. I hit enter, and now I went ahead and used the Stow key, which is down here, and then the X key to store that into X, right? And finally, I went in and inputted my original quadratic, the 2x squared plus 3x minus 4, and when I hit enter, I get 0. So that means that this answer checks. Okay? I really recommend that you do that, especially if you're taking a test. Okay? All right. Next problem. So this quadratic equation is x squared plus 6x plus 2 equals 0. It's in standard form, which is great. And now let's go ahead and decide what a, b, and c are going to be. So a, which is the coefficient of x squared, is 1. B, coefficient of x, is 6. And c, the constant, is 2. So we're going to substitute that right into the quadratic formula. So x equals the opposite of b, the opposite of 6, plus or minus big square root, b squared, 6 squared, 36, minus 4 times AC. A times C, 1 times 2. 4 times 2. There's going to be an 8 in here. Okay, all over, big fraction bar, all over 2 times A, and A is 1, so 2. And then under the radical, so the radicand, multiply 4 times 2 together first. So we get x equals the opposite of b, negative 6, plus or minus square root of 36 minus 8, all over 2. And then 36 minus 8 is 28. Square root of 28, all over 2. Now, the square root of 28, there's some perfect squares in here, aren't there? So we get to simplify. So 28, let's put over here. That is 7 times 4, right? 4 times 7. And when we take the square root of 4, that's a 2. So we get 2 square root of 7. So we're going to substitute here. We're going to replace the square root of 28 with a 2 square root of 7. And that's all over 2. Now we want to reduce this fraction down to its lowest terms. What we're not going to do is do anything with these two 2's that are here. Instead, we are going to look for a GCF. So we're going to factor a GCF from the numerator. So the negative 6 and the 2 square root of 7, they have a 2 in common, right? So we're going to factor out a 2, which is going to leave a negative 3 plus or minus square root of 7. And now we can reduce this 2 with that 2. So our two answers are negative 3 plus square root of 7 and negative 3 minus square root of 7. And again, these are irrational roots because of the square roots of 7. And now you can go to your calculator and check those answers to see if they work.